Hello. Hello and welcome to this video. First, as I do in recent videos, I'll show you how to download the book. So you can go to www.astrodoctor.org and you can click this second link available in Algebra. The date will change. I have updated this book yesterday, so it is yesterday's date. When you click this link, this book will be opened in your browser, and you can click the save button on your browser to save the PDF. And don't worry about the link and all. I will give the link in the description of the video. You can simply click that link. Okay, with that out, let's go to, okay. So we have solved till question number 280, and in this video we will solve 10 more problems, not 280, 290. So in this video we will solve question number 291 to 300. So as always, I will say that when I'm stating the problem, you should pause the video, and if you cannot solve the problem yourself, only then look at the solution. So without further ado, let's get started. Question 291 says that if alpha, beta be the roots of the equation x square minus px plus q is equal to 0 and nu n is equal to alpha to the power n plus beta to the power n, prove that nu of n plus 1 is equal to p nu of n minus 1 minus q nu n minus 1. So there is a mistake here. This should be nu of n, not n minus 1. Okay. So we see that p is nothing but sum of roots, that is alpha beta, and q is nothing but alpha beta, product of roots. So here we will put alpha beta, here we will put alpha plus beta. And for nu n, we will put alpha to the power n plus beta to the power n. For nu n minus 1, we will substitute alpha to the power n minus 1 plus beta to the power n minus 1. So that is what this question answer does. You substitute and then you multiply, two terms will cancel out, and what will remain is alpha to the power n plus 1 plus beta to the power n plus 1, which is equal to left hand side. Question 292 says that if alpha beta be the roots of the equation x square plus px plus q is equal to 0 and gamma delta those of equation x square plus px plus r is equal to 0, prove that alpha minus delta into alpha minus gamma is equal to beta minus gamma into beta minus delta is equal to minus q plus r. So we have alpha plus beta is equal to gamma plus delta is equal to minus p, alpha beta is equal to minus q, and gamma delta is equal to r. Also, because alpha beta are the roots of equation x square plus px plus q is equal to 0, alpha square plus p alpha plus q is equal to 0, and beta square plus p beta plus q is equal to 0. Now we substitute these values, and first we multiply alpha minus gamma is equal to alpha minus delta. We get alpha square minus alpha gamma plus gamma delta. We substitute the values of gamma plus delta and gamma delta. We obtain alpha square minus plus p alpha minus r is equal, which will be equal to, now if you look at this equation, alpha square plus p alpha is equal to minus q. So we put minus q, and then we get minus q plus r for the first one. Similarly, you can evaluate the second one, which will also be minus q plus r. Question 293 says that if alpha beta be the roots of the equation x square minus 2px plus q is equal to 0 and gamma delta those of equation x square minus 2rx plus s is equal to 0, and if alpha delta is equal to beta gamma, prove that p square s is equal to r square q. Alpha beta gamma delta be in GP, prove that p square s is equal to r square q. Alpha beta gamma delta be in AP, prove that s minus q is equal to r square minus p square. So here we let alpha plus beta, which will be 2p, alpha beta is equal to q, gamma plus delta will be 2r, and gamma delta is equal to s. So we are given that for the first one, alpha delta is equal to beta gamma. That is alpha by beta is equal to gamma by delta. So by componendo and dividendo, we have alpha plus beta by alpha minus beta is equal to gamma plus delta by gamma minus delta. We square both sides and we write left hand side as 1 minus 4 alpha beta by alpha plus beta whole square. You do this in inverse. So alpha minus beta goes to the top and alpha plus beta come to the bottom. So after that, alpha plus beta whole square minus 4 alpha beta is alpha minus beta whole square. And similarly, you do for the right hand side. So we get this equation, that is 4 alpha beta by alpha plus beta whole square is equal to 4 gamma delta by gamma plus delta whole square. You substitute and then you will get q by p square is equal to s by r square, which is the required condition here. Now if alpha beta gamma delta are in GP, then alpha by beta is equal to gamma by delta because common ratio is constant. And then it is similar to the first part. Now if alpha beta gamma delta are in AP, then alpha minus beta is equal to gamma minus delta. Then we square both sides and we proceed like this example. We have alpha plus beta whole square minus 4 alpha beta is equal to gamma plus delta whole square minus 4 gamma delta, that is 4p square minus 4q is equal to 4r square minus 4s. So s minus q is equal to r square minus p square. And that is how we prove all the three parts. Now we move on to question 294. It says that if the roots of the equation x square plus 2bx plus c is equal to 0 be alpha and beta, and those of the equation x square plus 2bx, these are capital A, plus 2 capital Bx plus capital C is equal to 0 be alpha plus k and beta plus k, prove that b square minus ac by capital B square minus capital A into capital C is equal to a square by capital A square. So we are given that alpha beta roots of this equation. So alpha plus beta will be minus 2b by a, and alpha beta will be c by a. For x, for capital A, this is for this equation, okay? And alpha plus beta plus 2k will be minus 2 capital B by a, and alpha plus k into beta plus k will be equal to capital C by capital A for the second equation. So once we have these two equations, what we are given is b square minus ac by capital B square minus ac. So we bring a square this side and we take b square minus ac to the numerator of the right hand side. So we can write this as b square by a square minus c by a is equal to capital B square by capital A square minus capital C by capital A. Now this is nothing but alpha plus beta whole square by 4. And this is nothing but alpha beta, and this is nothing but alpha plus beta plus 2k whole square by 4 minus this is alpha plus k into beta plus k. You look at left hand side, we get alpha minus beta whole square, and right hand side will also be alpha plus k minus beta minus k whole square. K will get cancelled, so both sides will become equal. Question 295 says that if the roots of the equation ax square plus bx plus c is equal to 0 be alpha beta, and those of the equation capital Ax square plus capital Bx plus c is equal to 0 be alpha plus k and beta plus k, prove that the same identity we have to prove. The only difference between these two equations is the coefficient of b, okay, in the equations, okay. So here it is 1, in the previous question it was 2. So we proceed like previous problem, okay. 295, okay, 295, yeah, this question. So again we do the same thing, we have the same result and it's almost the same question. So you can look at the solution of 295, and if you have questions, let me know. Question 296 says that if the roots of the equation x square plus 2px plus q is equal to 0 and x square plus 2qx plus p is equal to 0 differ by a constant, then show that p plus q plus 1 is equal to 0. So we have alpha beta as the roots of x square plus 2px plus q is equal to 0, and gamma delta be the roots of x square plus 2qx plus p is equal to 0. So alpha plus beta will be minus 2p and gamma plus delta will be minus 2q. Alpha beta will be q and gamma delta will be p. Now the roots differ by a constant term. Let that constant term be k. Then we can write that alpha plus k is equal to gamma and beta plus k is equal to delta. So from this we can say that alpha plus beta plus 2k is equal to minus 2q. We substitute for gamma plus delta in this equation. Now once we have this, alpha plus beta is minus 2p. So minus 2p plus 2k is equal to 2q. So k is equal to p minus q. Now we have gamma delta as p. So gamma delta is equal to alpha plus k into beta plus k. So we get alpha plus beta k plus k square is equal to p. Now we put alpha beta is equal to q, okay, from here, and alpha plus beta is minus 2p from here. So q minus 2pk plus k square is equal to p. That is, we have either minus 2p plus k is equal to 1 or p plus q plus 1 is equal to 0. So k would be equal to 1 plus 2p. Question 297 says that if alpha beta be the roots of the equation x square plus bx plus c is equal to 0, then find the equation whose roots are alpha by beta and beta by alpha. That is the one equation. Then we have alpha square by beta and beta square by alpha. Third one is alpha plus beta whole square and alpha minus beta whole square. Fourth is 1 minus alpha by 1 plus beta and 1 minus beta by 1 plus beta. And fifth is 1 by alpha plus beta whole square and alpha minus beta whole square. So from the given equation, we have alpha plus beta is equal to minus b by a and alpha beta is c by a. Sum of these roots is alpha by beta plus beta by alpha, that is alpha square plus beta square by alpha beta, which is b square minus 2ac by ac. And product would be 1. Alpha by beta into beta by alpha, when multiplied, it will be 1. So the equation would be x square minus b square minus 2ac by ac into x plus 1 is equal to 0. Now if you look at the second part, the sum of these roots will be alpha cube plus beta cube by alpha beta, which is equal to alpha plus beta whole cube minus 3 alpha beta into alpha plus beta by alpha beta, which is equal to 3abc minus b cube by a square c. Now if you see product of the roots, then beta will cancel 1 power of beta and alpha will cancel 1 power alpha. So the product will be alpha beta. So that will be the same, c by a. So the equation for these two will be x square minus 3abc minus b cube by a square c into c plus c by a is equal to 0. The third one is alpha plus beta whole square and alpha minus beta whole square. So sum of these two would be alpha plus beta whole square plus alpha minus beta whole square. So this would be 2 alpha plus beta whole square minus 4 alpha beta. Okay. Now, let me think a bit. Yeah, that is correct. So once we have this, we have 2b square by a square minus 4a by c, and product of these roots would be alpha plus beta whole square into alpha plus beta whole square minus 4 alpha beta. Once we have it, we substitute that and we have the equation. The fourth one is 1 minus alpha by 1 plus alpha and 1 minus beta by 1 plus beta. So we find the sum, and the sum turns out to be 2 minus 2 alpha beta. By taking LCM and cancelling out terms, you see minus alpha plus alpha will get cancelled. Minus beta and plus beta will get cancelled. 1 and 1 will be 2, and minus alpha beta minus alpha beta will be 2 alpha beta. Product will be 1 plus alpha plus beta plus alpha beta. So upon substitution, we have the equation as 2 into a plus b divided by a minus b plus c. Then we do the product. The product would be 1 minus alpha plus beta divided by 1 plus alpha plus beta plus alpha beta. So that is a plus b plus c by a minus b plus c. So the equation would be a minus b plus c, and this should be c, x square minus 2 into a plus b x plus a plus b plus c is equal to 0. Now the last one is 1 by alpha plus beta whole square and alpha minus beta whole square. So in this case, we write alpha minus beta whole square as alpha plus beta whole square minus 4 alpha beta. We substitute, we get a square by b square plus b square by a square minus 4c by a. And product would be similar. Instead of plus, there would be a product sign. So once you have the sum and product, you can always find the equation. Now we come to question 298. Find those equations whose roots are a reciprocal of the roots of b, equal in magnitude but opposite in sign to the roots of the equation x square plus bx plus c is equal to 0. So reciprocal of roots would be 1 by p plus 1 by q, where p, q are the roots, and p plus q is equal to minus b by a and pq is equal to c by a. So once we have the reciprocal of the root, sum of roots would be p plus q by pq, which is minus b by c, and product would be 1 by pq is equal to a by c. So the equation would be cx square plus bx plus a is equal to 0. As you can see, the coefficient of the first and last term get exchanged. The part B says equal in magnitude but opposite in sign. Once we have that, the sum would be 0. Okay, and product would be minus c by a, because they are opposite in sign. So the equation would be x square minus c is equal to 0. Question 299 says that if alpha beta be the roots of equation x square plus px plus q is equal to 0, find the value of alpha to the power 4 plus beta to the power 4 and alpha to the power minus 4 plus beta to the power minus 4. So this is a question of simple algebraic manipulation. Alpha to the power 4 plus beta to the power 4 is alpha square plus beta square. There should be a square here. Minus 2 alpha square beta square. And that is equal to alpha plus beta whole square minus 2 alpha beta whole square minus 2 alpha square beta square. We substitute the values. We obtain p to the power 4 minus 4p square q plus q 2q4 2q square. And alpha to the power minus 4 plus beta to the power minus 4 will be alpha to the power 4 plus beta to the power 4 by alpha to the power 4 beta to the power 4. We have evaluated alpha to the power 4 plus beta to the power 4 in part A, which is p to the power 4 plus 4pq square q plus 2q square, and alpha beta to the power 4 will be q to the power 4. Now we come to the last question. If alpha beta be the roots of the equation x square minus px plus q is equal to 0, find the equation whose roots are q by p minus alpha and q by p minus beta. The second part is alpha plus 1 by beta and beta plus 1 by alpha. So for the first part, sum of roots would be, we take LCM, it will be 2pq minus q alpha plus beta, and denominator would be p square minus p into alpha plus beta plus alpha beta. Now we put the values of alpha plus beta and alpha beta, we get pq by q, that is p. Product of these roots would be q square by q. So that is also q. So sum is p and product is q. So the equation would be x square minus px plus q is equal to 0. For the second case, sum of roots would be alpha plus beta by alpha beta, that is p plus p by q. That is p into 1 plus q by q. Product of these roots would be alpha beta plus alpha by beta plus beta by alpha plus 1 by alpha beta. Now alpha beta is q and 1 by alpha beta will be 1 by q. Alpha square plus beta square by alpha beta would be alpha plus beta whole square minus 2 alpha beta by alpha beta, that is equal to p square minus 2q by q. Once we have sum and product, you can always find the equation. So with this, we come to the end of 30th set of problems on quadratic equation, and I hope that you are finding this series useful for your studies, for clearing your concepts, practice, and exams or tests. So if you find this video useful and informative, please subscribe to the channel if you are not already subscribed. Like the video, share it on social media, share it with your friends, because the objective of the video is to reach as many people as possible. So some people may not want to share it to friends, but that is not good. You should always share it to your friends. And I will see you in the next video with 31st set of problems. Thanks a lot for watching. Enjoy.